to write equations or the function rules for piecewise functions. Okay, so but first we need to know what's a piecewise function. So if you could focus your attention to the right side of the screen, I want to this is just like a small definition for what it is. It's not a technical definition, but some way to explain it for you to understand. So a piecewise function is a function that is a combination of one or more functions. So one or more functions. And so the rule for a piecewise function is different for the different parts of the pieces of the domain. So let me explain that with a graph. So here is an example of a piecewise function. You can see that this function is composed of several pieces. Specifically, it has 1, 2, 3, 4 pieces. And so the function rule is different for each part of the piece. So our job is to create the rules for every single piece and write it in function notation like I want to show you now, okay? So the first thing to note is that you need to define the domain for each part. The domain for each part is the interval over the x-axis, on the intervals of values on the x-axis for which each part exists. So, for example, if you look at part A, let me call this one part A of that function, you will see that that part of the function exists from, see the arrow here is saying that it goes on forever from negative infinity. It goes to negative infinity and it stops existing when it gets to, so this is 0, negative 1, negative 2, negative 3. So at negative 3, that part of the functions stops to exist and another part starts to exist from there. Okay, so what we're going to do is we're going to name the domain for part A. Okay, like we discussed in class, if you look carefully, I want to highlight the portion of the x values for which that function exists. So that function exists all the way like that and going all the way to infinity, negative infinity on the left. So we can say that part of this function here, part A, exists for all values of x that are less than negative 3. The reason it's not less than or equal to is because you can see the function actually does not include negative 3 in x value of negative 3. See, this is being open. This part is open. The one I highlighted is open. And so that's why the inequality is also just not including the equal sign. So that's the domain for the first part. All right. Now, let's write the rule for that part. Generally, we're going to write the rule using this function notation like this. We're going to say f of x equals, and then we're going to define all the 4 pieces like this. Let me make it a little bit larger than that. So we're going to make it all 4 pieces like that, okay? So now what we're going to do is we're going to write the rule. We're going to write the equation for this part. I'm going to highlight in blue. This part I'm highlighting in blue. We're going to write the rule for it. Okay? Now you can see that's just a line that's defined by y equals whatever the value over of this point is. So that portion is simply y equals 1, 2, 3. It's called y equals 3. So I'm going to write that as f of x is like y equals, so it's equals 3. And then the domain for that part is from negative infinity all the way to 3, or x is less than negative 3. Okay, we're done with part A. Now we go to part B, which I'm going to highlight in purple. So we're going to do part B now. This is part B. All right. Now, if you look at the x values, if you trace this down to the x-axis, you will see the x value for that portion is highlighted in purple. That's the x values for which this function exists. So going by the same way of naming this domain or writing the domain, you will see that that portion includes it goes from -3 all the way to 1 to all the way to 2. So that place right here is 2. This place right here is 2. So we can actually see that the domain for this function highlighted in purple is from -3 all the way to 2. So now we're going to write the rule for that portion. Okay, let me remove the highlight for the time being, and then we write the rule. Let's see. All right. Oops, it's not coming back. So, but we can actually see, we can find the let me zoom in to find the slope of this function. Zoom a little bit. You can find the slope of this function. All right, let's take a lattice point, which is the beginning there. There's another lattice point right over here. Okay, so we can find the slope. The slope is sort of like here. As the slope over here. We can use that to find the slope. So this is rise of 1 and a run of 2. So the slope is 1/2. But the y-intercept is not quite showing at a particular place. So we don't know what that place is right here. We don't know what this place is. So we need to use point slope formula to find the equation of the line. So let's use a point slope formula, zooming back. So I'm going to write the point slope formula over here. Y minus y1 equals mx minus x1. Now, I know the slope is 1/2. So m is 1/2. And I know for sure this point, let me zoom back in. I know this point is at -3 and 1, 1. Okay? -3, 1. So I'm going to use that to find the equation using the point slope formula. All right, so let's plug it in. All right, zoom back again to show those kids that might have trouble with identify what is x1, y1. I hope you don't have that trouble. So this is x1 and that's y1, okay? So y1 is 1 and x1 is -3. We're going to plug it in back again here. So let's plug it in. Y minus 1 equals 1/2. X minus -3 will become +3. Okay, so it becomes +3. So now we're going to simplify this by distributing the 1/2 into each term. Okay, 1/2 x and then 3/2 plus 3/2, because 1/2 times 3 is 3/2, because 3 times 1 is 3. If you put a 1 here, 2 times 1 is 2, 3/2. So, and then we're going to add 1, okay? We're going to add 1 to get rid of the, to get y by itself. So, +1 and +1. This one is going to go away. It's going to have y equals 1/2 x. And then we're going to do 3/2 plus 1, right? So 2 times 1 is 2, plus 3 is 5. So it's actually 5/2. 5/2. All right. Let's go back. 5/2. So actually the equation for this line is going to be 1/2 plus 1/2 x plus 5/2. So I'm going to copy that to the rule, function rule. Let's go back over here. So it will be, the second part in purple will be 1/2. Let's use the same column. All right, so it's going to be 1/2 x plus 5/2. That's the rule for the one in purple, or section B over here. So, and then we know the domain. That's, the x value is from -3 negative 3 is less than or equal to x, and then less than 2. The reason being that, see, this part of the graph, the beginning of the graph is included. So we have the rule is saying it's included. See, it's included. That part I'm highlighting in yellow is included because the beginning of the graph is included. But the second part of the graph, highlighting in yellow here on the right here, is not included. So it's less, just less. That's the domain for that part. Okay. And now we go to the second, another section of the graph. Let's go to another part, C. I want to highlight that in yellow. That part is in yellow over here. All right. And the domain, I want to highlight it on the number line on the x-axis, also in yellow. It seems the yellow is not very clear, so let's go. It's going to start from there and end right there. Okay. So we can see the domain is from 2 all the way to 6. All the way to 6 right here, because that's where that graph is covering. Okay, it's covering that area there. All right, so we know the domain is from 2 to 6. Now let's find the rule for this graph, for this portion. Okay, so the rule, we're going to find the slope. All right, we see if you pick a lattice point here, another lattice point here, we can see that the slope is 1 over 1, but it's a negative 1 because you're going down. So the slope is negative 1. We can actually trace this graph up instead of using the point slope. Let's try to trace it up to the y-axis to see if we can find the y-intercept. We can go like that, like that, like that. So we're going to see that actually this is going to cross at y equals 1 if we trace it up using the same formula, the straight line. So the y-intercept for this is 1. So we know slope is, the slope is negative 1 and the y-intercept is 1. So if we use y equals mx plus b, we will find that y equals negative x plus 1. That is the equation for part C. So we're going to write that rule over here as y equals, or f of x equals negative x plus 1. And then the domain is from negative 2. No, it's from 2 rather. And it's not included. See, if I zoom in again, that 2 right here, let me circle it, is not included. So I am going to say it's just less than. It's less than. And then less than x. But the end part right here, I'm going to circle it. This part here is included. So, and if you trace it, goes to 6. So it's going to be less than 6. I hope you're not getting dizzy with zooming in and out. So less than or equal to 6. Less than or equal to 6. Okay, that's the domain. Now we are left with the last part. The last part is going to be part D over here. Let's call it D. This one is simple and straightforward. It's just a straight line. It's a horizontal line rather. So horizontal line, we know we can just trace this to the y-axis, and the equation is just y equals 2. Let's trace it. If we go like that and continue, you'll get to 2. So because y equals 2 is the rule for that. Y equals 2. Go back to the definition of the function and write 2, comma. Now the domain is going to start from 6. So let me highlight it in blue, okay? From here all the way to infinity, positive infinity, because it has this arrow on it, so we need to consider the arrow. So the domain is going to be from 6 to infinity, which is just x is greater than or equal to 6, because this part that I'm circling is included. All right, that point, that 6 is included because of that shaded in. So it looks complicated, but it's not really. You can see there. let me rewrite this thing, curly bracket, to include everything. So it includes all of those. Now, that is the function rule for this. Now, if you go back to the definition, we're saying that a piecewise function is a function that is a combination of one or more functions. So each of these 1, 2, 3, 4, 1, 2, 3, 4 is a different function. So, and the rule for the piecewise function is different for different parts of the pieces of domain. It's different. So the rule here is 3. The rule here is 1/2 x plus 5/2. And the rule here is negative x plus 1. And the rule here is 2. So the rule is different for each part. So I just have one more check for understanding for you to do for me. If I want to make one little piecewise function for you right here, and you try to determine the function rule. Okay, I'll make it very, very simple. Here it's going to start from somewhere over here, and it's going to go all the way to here. And then here is another one. It's going to start from down here, open, and it's going to go like that. And it's going to close over here. And then the last one is going to go from right here and go to infinity. Okay. Let's see if you can write the rule for that. You can pause the video and try to write the rule for that, okay? Okay, hopefully now you did it correctly. Let's come back and write it together. So from here, I want to highlight them in 3 different highlights. This is the blue function, piece. This is the yellow function, piece. And then this is the purple function, piece. Now, that means when I make my function rule, f of x equals, I'm going to have 3 pieces. All right, the first piece is a straight line, and it goes through y equals 3. So y equals 3. And so it's going to be just 3. And the domain is going to be from, this is negative 5, negative 6, negative 7, negative 8. So it's negative 8 all the way to 1. So it's going to be negative 8 less than x less than or equal to 1. The second piece is just y equals x. I mean, the slope is 1. The slope is 1. And then if you trace it, it will be at negative 2 down here for y, mx plus b. So it's going to be 2. It's going to be x minus 2. And the domain is from 1 less than x less than or equal to 5, because it ends at 5 right there. And the last piece is just y equals to negative 2. Let's put it over here. It's negative 2. It's negative 2. And the domain is going to be from 5 to infinity, or s is greater than 5. X is greater than 5. Hopefully, this is helpful. You can watch other video or watch this over and over again until you get it.